In January 2023, a 64-year-old woman living in a rural area of southeastern Australia began suffering from what initially seemed like a cluster of unrelated but concerning symptoms. At first, it was the kind of discomfort that might be brushed off. Abdominal pain, mild fever, night sweats. But over time, her condition grew more disturbing. She began to forget things she had just said, misplaced familiar objects, and occasionally stared blankly at family members mid-conversation. As the weeks passed, her memory lapses turned into alarming cognitive declines. She experienced vivid hallucinations, saw people who weren't there, and lost track of time. By the time she was admitted to a local hospital, she was confused, agitated, and mentally disoriented to the point where everyday life became unmanageable. Doctors ran test after test, suspecting everything from autoimmune encephalitis to a form of early onset dementia, or even a malignant brain tumor. None of the usual suspects seemed to explain the rapid progression of her symptoms. In desperation, she was referred to Canberra Hospital for more advanced imaging and evaluation. There, an MRI scan of her brain revealed something that set off alarm bells: an 8-centimeter lesion on the right frontal lobe. Given the size and location, the initial assumption was a tumor, possibly cancerous and in urgent need of surgical removal. The neurosurgery team prepared for what they believed would be a high-risk but standard tumor excision. But when they opened her skull and began to carefully examine the affected brain tissue, what they found horrified even the most experienced members of the team. Instead of a tumor, they uncovered a living organism, a long, writhing, red roundworm, about 8 centimeters or 3 inches in length. Still alive and actively moving, the worm had been burrowed deep in her brain, feeding and possibly growing. It was gently extracted and sent for immediate analysis. The parasite was identified as Ophidascaris robertsi, a type of roundworm native to pythons, particularly carpet pythons, which are common in parts of Australia. This was not just unusual, it was unprecedented. This was the first recorded instance of this parasite being found in a human being. How such a thing could happen became the focus of intensive investigation. The woman had no pet snakes, no history of exotic travel, and no obvious reason to be infected with a parasite that only lives in reptiles. But she did live near a lake surrounded by dense vegetation, a natural habitat for carpet pythons. Her lifestyle included foraging for native plants, especially warrigal greens, which she used regularly in her cooking. The prevailing theory is that python feces containing the parasite's eggs had contaminated the plants she gathered. It's likely she ingested the eggs unknowingly. In most human cases involving accidental parasite ingestion, the immune system neutralizes the threat before it causes harm. But in this case, something went terribly wrong. Once inside her body, the eggs hatched in her intestines, and the larvae began a horrifying journey. They entered her bloodstream, traveled to her liver, then her lungs, and finally, against all biological expectations, found their way into her brain. This kind of misdirected parasitic travel is known as aberrant migration, and it's rare, even among parasites. This case rattled the medical community to its core because it shattered several long-held assumptions. First, Ophidascaris robertsi was never believed to be zoonotic. It had only been documented in reptiles and had never crossed over to mammals, let alone humans. Second, the parasite wasn't just surviving, it was thriving. The worm had undergone at least one molt while inside her brain, a clear sign that it was maturing and adapting to its new host. The thought of a reptile parasite evolving to survive in human tissue is both fascinating and deeply alarming. It suggests that under the right conditions, even parasites with no history of human infection can find a way to adapt. Third, treatment options were extremely limited and dangerous. Anti-parasitic medications like albendazole could potentially kill any remaining larvae, but they also posed a high risk of triggering deadly inflammation in the brain. A dying parasite in neural tissue can release toxic proteins, which the body's immune response might attack, causing fatal swelling or seizures. The woman's recovery was partial. The worm was removed before it could cause further structural damage, but it had already wreaked havoc on her cognitive function. She now lives with permanent neurological deficits, including memory impairment and difficulties with executive functions like planning, focusing, and processing information. Her case was quickly documented and published in the CDC's Emerging Infectious Diseases Journal in September 2023. Since then, it has become a pivotal case study in discussions around emerging zoonotic diseases, those that jump from animals to humans. Her story has been shared in medical conferences, scientific symposiums, and even international news outlets. It serves as a harrowing example of how rapidly our assumptions about parasitic behavior and host barriers can be proven wrong. What makes this case even more disturbing is the context in which it occurred. Experts in parasitology and infectious diseases have warned for years that human encroachment on wildlife habitats, coupled with the accelerating effects of climate change, is increasing the risk of animal pathogens jumping to humans. As more forests are cleared, as more people live closer to wild animals, and as ecosystems are disrupted, the chances of spillover events grow. Viruses like SARS-CoV-2, Ebola, and Nipah have already shown us how dangerous such jumps can be. This case adds parasitic roundworms to that growing list of threats. A python parasite in a human brain might have seemed like a horror movie scenario in the past. Now, it's a documented reality. There are still many unanswered questions. How exactly did the worm manage to evade the body's defenses and reach the brain? Could this happen again? Are there other cases we've missed? Patients who died before a proper diagnosis was made? Researchers are racing to understand more about this parasite's life cycle, its mechanisms for host invasion, and what this case means for global health. In the meantime, the woman's life has been forever altered. What started as mild abdominal discomfort spiraled into one of the most bizarre and unsettling medical cases in modern history. Her experience has opened a door to a new realm of infectious disease research, one filled with uncertainty, but also urgency. This story is more than just a medical oddity. It is a wake-up call for the medical world and for society at large. The boundaries between species, once thought secure, are increasingly blurred. What happened in southeastern Australia may have been a freak occurrence, but the factors that enabled it, proximity to wildlife, environmental disruption, and human behavior, are becoming more common worldwide. And if a python worm can find its way into the human brain, it forces us to ask, what else might be lurking just beneath the surface of our shared ecosystems, waiting for the chance to cross over?